Hey guys, Mr. Middleton here. Going through our first lesson in Geometry, Unit 1, Lesson 1, Points, Lines, and Planes. By the end of this video, you should be able to define a point, a line, and a plane using standard geometric representations. And you should be able to identify and name the intersection of specific points, lines, and planes. Alright, we'll start off kind of with knowing what a definition is. Okay, a definition is not exactly what you've understood it to mean before. Definition. At least in the mathematical world. So for mathematicians and for us this year, a good definition, has a few characteristics. Okay, first, it has to use clearly understood terms. Okay, if we use things that nobody knows what they mean, then it's not a good definition. It should be commonly understood and already defined. Okay. It is objective. Okay. So we would avoid words such as large, sort of, or some, kind of, things that mean it sometimes is and sometimes isn't, or things that are not based in fact. Okay. And then it is not disprovable. Disprovable. So if you want to, you can take a second and think about how you would define truck or how you would define truck or dog. Okay, and giving you a hint, I guess it's almost impossible to do right now. Okay, if you think about truck, you might think something with four wheels, but a car can have four wheels, or an airplane. I don't know how many wheels they have, but they have a lot of wheels. And some trucks have 16 wheels. But does a truck have to have 16 wheels to be a truck? Can that still be a truck without 16 wheels? What if a three-wheeled truck? I don't know if there are three-wheeled trucks, but I'm sure there are three-wheeled trucks. There's a lot of different ways that you can have a truck, and it's kind of hard to define it so that it's objective and not disprovable. Okay, because most anything you say right now, I would be able to give you an example of something that follows those characteristics, but is not a truck. Okay, same thing goes for dog. Okay, if you said something that barks, it might be a seal with four legs that you can train and keep in the house. It could be a cat. I don't know, wags its tail. I don't know if lions wag their tails. Okay, but it's pretty hard to define those things so that they're objective and not disprovable at the moment. Okay. In geometry, though, we have a few undefined words, or undefined terms. Okay. And undefined terms, they are classified this way because to define the words, you need to use words that need further defining. And so, therefore, the following are not definitions. These are not definitions, but they're understandings of the meanings, or generally accepted understanding. See that? Okay. Okay, so these next three terms that we're going to talk about are known as the undefined terms. Okay, a point. Okay, we'll use these a lot. A point is a location in space, and it has no size. Okay, and it's represented by a small dot and a name using one capital letter. A line is a series of points extending in both directions forever, with no end, and it's named by any 2 points on the line, or a single lowercase, usually italicized letter. Okay, all right. You'll see that when I write, I usually write in uppercase, but when I'm doing my geometry and I'm listing things and labeling parts, I do follow, and you should also follow those defined or set rules for the naming system. So this example says name the line in 4 different ways. Okay, you can use any 2 points to name a line. So I'll name it line PT, and I need to make sure that I put this line over it so that it knows it continues forever. I can name it line PW, and I can name it line TW. I could also call it line M. I could just say M. I guess I don't have to write M. Okay. I could also call it line M. One thing to notice is that reversing the order is not a new way to name a line. Okay. So PT and TP are the same thing, same as PW and WP. It's not a new way to name it. It's just flipping the orders. It means the same thing. Okay. In the example above, we say that the points P, T, and W are collinear. Co means together, linear in a line. They are in a line together. Okay, they are on the same line. So since P, T, W are all on the same line, they are collinear points. So now using that information, we will answer these questions on the back. Are E, F, and C collinear? Okay, you can see these, E, F, and C. Yep, they are collinear. Okay, what line did they lie on? They lie on M. Okay, M is a lowercase letter, so I know that it's not marking a point there. It has to be called talking about that line. Are C, D, and P collinear? Well, C and D are, but P is off on a different line. So no. If you ask me points and one point's not on the same line, then the answer is no. Okay, therefore that one's nothing. And this is tricky. Are P and C collinear? You might not think so, but the answer is yes. It's kind of tricky because question 3 above represents our first postulate, okay, or axiom. Well, I'll probably use the word postulate more than axiom. But our postulate, which is an accepted statement of fact. And that postulate says that through any 2 points, there is exactly one line. So through any 2 points, there is exactly one line. So through P and C, even though there's no line drawn, you know that there is a line that goes through those 2 points. Okay, it doesn't need to be drawn for you to know that. Okay, the last undefined term is a plane. Okay, which is a flat surface with no thickness. It is named by at least 3 non-collinear points. So if collinear means on the same line, non-collinear means not on the same line. 3 points that are not on the same line. Or you can do a single capitalized letter. I should just say capital letter. Okay, a single capital letter. All right, so using those rules, we can name this plane in this example either plane Q, because you see it over here, it's by itself, it's not listed next to a dot. We could name it plane ADB, 3 points here, and we could name it DBC. Again, any of those orders really doesn't matter, the order that you use it in. Okay, as long as the lines are not collinear, or points are not collinear. Okay, and that's why we can't use ABC. ABC is on one line. Okay, one line actually exists in many, many, many different planes. If you need to see that, you can ask me about that. Okay, and that's why I can't name it with one line. Okay, we say that the line and point D are coplanar. Okay, even though point D is not on that line, it does lie in the same plane. If you imagine this being a field, you know, this is a straight line and this is a dot. Well, they're both on that field. They're both on that same plane. The third postulate says that if 2 planes intersect, then they intersect in exactly one line. And it's easy to visualize if you use a room. If you use the front of the room and the side of the room, when they intersect, they make a crease in the corner of the room. That crease is the line that they intersect in. And the final postulate today says that through any three non-collinear points, there is exactly one plane. Okay, and that's how we name a plane. So going through this last set of problems, it says name the plane representing the top of the box. So the top of the box, we have E, F, H, G. So I'm just going to call it E, F, G. That's the plane. I can choose any three letters. What's the intersection of G, H, and CG? If you want to pause this and try this on your own, try it and then come back for the answers. That intersection will be G. What's the fourth point of BFH? So BFH, that looks like the front of the box. So what else is on the front of the box? A. What is the intersection of EDA, that's the left side, and CAB, that's the bottom? So where do they intersect? Well, what's on the left and the bottom? DA. Call it line DA. What is the intersection of EG, okay, this is that back corner, and CDG? CDG is the back side. So that intersection is that whole line. EG is a part of that plane. What is the intersection of GH and FAB? FAB is the front, GH is kind of that top corner. They intersect at point H. And this last one's tricky. It says, what is the fourth point of EDB? ED, B is up here in the front. There's actually a plane through here. Okay, kind of tricky, just like those 2 points through any, a line through any 2 points. There's a plane here. Okay, it's in the middle. It's not drawn or seen, but it's there. That last point would be H. Okay, all right. If you need to rewind or revisit, sorry, let me show you those last two. If you need to rewind or revisit, feel free to do that. We'll have questions and practice right after this. See ya.